Hi everyone and welcome to today's video. My name is Emmanuel Olega and I'm a math teacher and a software engineer. So today I'm introducing a new topic. Today I'll be introducing the topic of integration. And I expect this topic to be a follow-up to someone who has learned the topic of differentiation, because this is going to be more of the reverse of it. So we're going to be introducing integration in today's video. I'm going to be sharing a lot of examples from UNEB and as many examples that I could actually find out, and I'll be explaining it in the most basic and easiest way to understand. Without wasting time, let's introduce the topic of integration. Alright, so we're going to move on to that next topic. So today's topic is going to be integration. So this is going to be our next part in calculus. So this is where we are right now. It's integration in the calculus section. Alright, let's learn integration. Alright, so integration is the act of obtaining a function from its derivative. Integration is considered also to be the reverse of differentiation. So reverse basically means opposite. So if we understood differentiation, this is actually basically the opposite of it. So integrals are also, for this reason, called antiderivatives. That's because they are basically the opposite of differentiation. So this is how the integration process works. So now, unlike what we did in differentiation, in the process of integration, we increase the index power of the variable by 1. So remember, in differentiation, we are reducing the index power, we're subtracting a 1, but now we're going to add a 1 in integration to get the new power of the integral. So we then divide the old coefficient by the new power to get the new coefficient of the integral. So now after that, we're going to divide that by the new power. So this is how basically we have it. So this is our integration sign. So if we have the function, if we have ax to the power n, and we're being told to integrate that, what we do is to the x, we're going to add a 1, and then we're going to divide everything. We're going to divide the a by n plus 1 by what we actually added. By this coefficient of the new power, we're going to divide it by a, and then we're going to add a c. Now this c is going to be a constant. Alright, so dx is the differential coefficient, and then a is the old coefficient, n is the old power, then a over n plus 1 is the new coefficient of the integral, and n plus 1 also represents the new power of the integral. Now c is basically a constant of integration. So basically, because we are actually reversing, so this is basically an antiderivative, so that simply means we're going backwards. So imagine we had a function that was like 2x plus, actually let's call it 2x squared plus x plus 2, let's say plus 3 actually. So remember, when we differentiate this, we get 4x plus 1, and you can actually see that this 3 basically disappears. So now what happens when we do integration is actually taking this back to the original. So as you can see, if I integrate the 4x, what I do is I add a 1 here. So when I add a 1, so remember that this is now basically to the power 1, I add a 1 to it, and of course that x shall become x squared. And then, as we said, that new power, we divide it by this a. So we'll have a 4 divided by 2, which is 2. And then where there is this 1, remember that basically means that we have an x that is to the power 0. So we add a power 1 to that 0. So 0 plus 1 is 1. So we shall have x, and then we divide, so 1, so to be this 1 divided by that new power 1, which is actually 1. So we just have an x. Now this 3 is actually going to be a little bit difficult to recover, because we don't know what exactly that constant was when we actually go back in reverse. So that will actually depend. So what we're going to do is, because it could be anything, it could have been a 3, a 4, a 5, a 6, it could have been the same. That's why in integration we just include a plus c. So a c is going to represent the general constant of whatever it could have been. So let's look at indefinite integrals. So there are two different kinds of integrals. There are those that are indefinite and those that are definite. So let's look at indefinite integrals. So an indefinite integral is an integral expressed without limits. So that's basically the difference. An indefinite integral has no limits. So here you have to add a arbitrary constant called constant of integration, that is the c. So remember, we only add a c when it comes to indefinite integrals. So indefinite integral will look like, so if we have this, if we're told to integrate x squared plus 4x, when we take this back, it will actually become x cubed over 3 plus 2x squared plus c. So this is actually the integral. As you can see, we add a c because this is an indefinite integral, and you can actually say there are no limits to the integral sign. So let's look at some examples. So we're being told to find the integral of x cubed plus 5x plus 8 over x power 4 with respect to x. So what do we do here? So we're basically being asked to integrate this. So that's actually what we mean. So now basically what you can see is actually this, because there is an addition sign between each one, we can actually separate each one of them and have them in their own integrals. This is actually possible. So now let's have them that way. Now we can see that here where we have 8 over x power 4, we can actually convert this and have x power negative 4, and this will actually be simpler to deal with. Alright, so now we integrate each one. As you can see, where we have the x cubed, you can actually see that we know its coefficient is 1. As you can see, the coefficient is 1. So we have a 1 divided by the new power. So then the new power shall be 3 plus 1. Then we'll have to also divide it right here. So we have 3 plus 1. And then right here, we can actually see that where we have 5x, the coefficient is 5. And then x is to the power 1. So we're going to have to add a 1 to that power 1. So it will be x1 plus 1 over that new power of the coefficient. So it will be 1 plus 1. So it will be 5 over 1 plus 1. And then right here, we can actually say to have a negative 4. We shall have a negative 4 plus 1. Then we shall divide that new power, that new coefficient, power, over the 8. So that's why you have 8 over negative 4 plus 1. So now as you can see, we have a quarter here. 3 plus 1 is 4. So we have 1 over 4 x power 4, because this 3 plus 1 is 4, plus 5 over 2 x squared minus, the reason I have a minus here is because you can actually see that negative 4 plus 1 is actually negative 3. So its negative sign will actually affect this plus sign. So that's why I have an 8 over a 3x to the power negative 3 plus c. But now this can be best simplified. We can actually take this back down to the denominator, and we'll have 1 a quarter of x power 4 plus 5 over 2x squared minus 8 over 3x cubed plus c. Now as you can see, we've added the constant of integration right at the end, and that is very important. So let's look at another question. So being told to find the integral of bracket 2t plus 3 squared with respect to t. So how do we solve this? So basically here we can actually just open those brackets. So let's open those brackets, and we'll have 4t squared plus 12t plus 9 dt. Now since we are dealing with t, since everything is with respect to t, that's why we have this as dt. So now we can actually separate each value into its own integrals, and that's what we have. And then as you can see, now we basically can integrate. So as you can see, once the integral sign disappears, we add a plus c to the end. So we have 4 over 2 plus 1 into t 2 plus 1 plus 12 over 1 plus 1 t 1 plus 1 plus 9 over 0 plus 1 9 0 plus 1. Now the reason we add a 0 here is because basically here we can actually assume that there is a t value, but the t is to the power 0. That's why we don't see it. And now t to the power 0 is 1. So 1 times 1 is, 1 times 9 is 9. So basically we must have a t to the power 0 right there. So add a plus 1 to that, and we'll have a t over that. So now here we have 4 over 3 t cubed plus 12 over 2 t squared plus 9 over 1 t plus c. Now this 12 divided by 2 is 6. So now basically the answer will be 4 over 3 t cubed plus 6t squared plus 9t plus c, and that is the answer we are looking for. Alright, so moving on to question number 3. This is slightly different, but it's also doable. So now we have everything with respect to y. So how do we solve this? So this is the equation we have. We can actually separate each one into their own individual integrals. Now we know that a root y is the same as y to the power a half. So that's what we have right now. And then now we can actually integrate each one. So now here we have a 3 over 2 plus 1 over, and this coefficient here is 1. So 1 over 3 over 2 plus 1 minus. So we have y to the power a half plus 1. Now here the coefficient is also 1 over a half plus 1. Then right here, we're going to assume that there was the coefficient of y being to the power 0, and then we're going to add a 1 to that, so 0 plus 1, and then we're also going to divide it here, 0 plus 1. So now basically we have 2 over 5 y to the power 5 over 2 minus 2 over 3 t to the power 3 over 2 plus 1 over 1 y plus c. So therefore our final answer shall be 2 over 5 y to the power 5 over 2 minus 2 over 3 t to the power 3 over 2 plus y plus c, and that is the answer we're looking for. Alright, so now that's it with indefinite integrals. Let's look at what definite integrals mean. So now a definite integral is basically the opposite of indefinite integrals. So a definite integral is an integral where the limits are given. So it's as simple as that. So therefore we do not add a constant at the end of integration. So here are the questions. So here we don't add a constant, so that is basically the biggest difference. So let's look at an example, and this will allow us to understand it better. So we have to evaluate this integral of, so we have limits. So we have the upper limit is 4 and the lower limit is 2 into x cubed plus 4 dx with respect to x. We have to integrate that. So now basically the first step we're going to do is basically you're just going to evaluate the integral normally. So that's going to be the first step. So let's just find the antiderivative. So now we can actually separate this. So this, as you can already see, that we can actually already integrate directly. So you can actually see where we have this x cubed, we're going to have an x3 plus 1, then its coefficient is 1 over 3 plus 1, plus, now here we're going to assume that there was an x to the power 0, which is obviously 1, then we're going to add a 1 to its power, so you have x0 plus 1 over 0 plus 1. Now basically we're going to put everything in brackets like that, and we're going to have the limits outside. So now when we solve this and simplify, we end up having a quarter x power 4 plus 4x. So now that we have this, the next part is going to be for us to substitute the limits in. So now what we're going to do is we're going to plug the upper limit first into the antiderivative, and then we're going to subtract the result when the lower limit 2 is also plugged in. So that's what we're going to have. So we're going to make the difference. So now this is the group where we have the upper limit plugged in, and then this is the group where we have the lower limit plugged in, as you can see. So now we're going to subtract and find the difference. So now here we have 64 plus 16, then right here we have 4 plus 8. So we have 80 minus 12, and our answer shall be 68, and that is the answer we're looking for. Alright, let's look at another question. We're being told to evaluate. So we have this integral with the upper limit being 5 and the lower limit being negative 2. And then we're being asked to integrate 6x squared dx. So let's work on that. So how do we do that? So now, basically let's integrate this. We are going to add a 2 plus 1 is to the 1 plus 1 to the power, then divide by 2 plus 1. So this becomes 6 over 3x cubed. But we know that can also be expressed as 2x cubed. So now next we're going to plug in the limits. So we plug in the upper limit, then we subtract where in the case where we plug in the lower limit. So this is where we plug in the upper limit minus that group where we plug in the lower limit. So we have 250 minus bracket negative 16, which is the same as 250 plus 16, of which the answer shall be 266. So next we're being told, given that so this is the integral, 2 is the upper limit. Now the lower limit is a, and we don't know what that lower limit is. 2y minus 3dy being equal to 0. So we're being told to find the value of a. So basically in this case we're being asked to solve for the lower limit. So how do we solve this? So basically we're going to just first integrate as usual. But now everything here we're being told is equal to 0. Let's first integrate that. So integrate this. So for this group we have 2 into y 1 plus 1 over 1 plus 1 minus 3. We're going to assume that we have y power 0 right here. So we have y 0 plus 1 over 0 plus 1. So when you solve that, we have y squared minus 3y. Then we're going to have these in brackets, and then we'll have the limits outside. So next we're going to plug in the upper limit and the lower limit and have that difference. So this is the group where we have the upper limit plugged in minus the group where we have the lower limit plugged in. So we have 4 minus 6 minus bracket a squared minus 3a being equal to 0. So next we have negative 2 minus a squared plus 3a being equal to 0. So we arrange this and we have a quadratic equation. So now when we solve for the quadratic equation, we can see that either a is equal to 1 or a can be equal to 2. But now, as we can already see that we already have the upper limit as being equal to 2, it means we cannot have, there is no way the value of a can actually be 2. Or actually, the value of a cannot be a value greater than 2 in other ways. So that's not possible. So now we can only have a as being equal to 1. So therefore, a is equal to 1. Alright, so another question we're being told to evaluate. So this is another integral. So the upper limit is 2 and the lower limit is 0.5. Evaluate x squared plus 3x plus 4 over x power 4 dx with respect to x. So this is another easy one. So how do we solve this? So now first of all, we're going to separate x power 4 to each value in the numerator. So that's how we have it this way. So now when we reduce each value, then we're going to separate each one, and each one is going to be in their own integrals, just for us to solve this quickly, but basically it doesn't change the meaning. So now here we can actually see when this reduce, we have 1 over x squared. When this reduce, we have 1 over 3 over x cubed. Then when these reduce, actually these remain as they are. So now this is what we are left with. So next we can actually move the denominator values to the numerator. So we have x power negative 2 right here. Here we have 3x power negative 3, and here we have 4x power negative 4. And now next we can actually integrate. So in integrate this side, here we have negative 2 plus 1 over negative 2 plus 1. Here we have negative 3 plus 1 over negative 3 plus 1. Here we have negative 4 plus 1 over negative 4 plus 1. So when you solve these, this is what we are left with. So now this, because of this negative sign, we are left with this being over a negative 1. Then right here, this also gives us a negative 2. So this affects this sign. So you have 3 over 2, x power negative 2 minus. Now here the negative sign, the plus sign is also affected because negative 4 plus 1 is negative 3. So that's why we have it that way. So now basically when we solve this is actually how they look in the most simplified form. So we take the values back down, and this is what we have. So next we're going to plug in the limits and then find the difference. So this is the group where we've plugged in the upper limit minus the group where we've plugged in the lower limit. And what answers do we get? For this group we get negative 25 over 24, and for this group we get negative 56 over 3. So when we open brackets, we have negative 25 over 24 plus 556 over 3, of which the answer is 141 over 8, and that is the answer we're looking for. Alright, so question number 5, we're being told to evaluate. Now this is another integral, and the limits are 9 as the upper limit and 4 as the lower limit. So this is root of x minus 1 over root of x dx. So we're being told to solve this with respect to x, so evaluating it. So let's solve this together. So now first of all, we're going to first solve those values in the bracket. So we know that root of x is basically x to the power half, and then 1 over root of x can be the same as x to the power negative a half. So that's what we have. So now we can separate each one into its own individual integrals. So this is x, and it's going to be a half plus 1. Then its coefficient is obviously 1 over a half plus 1 minus this one is x to the power negative a half plus 1, and then its coefficient is also 1. Alright, so now when we solve this, this is what we have. So we're left with 2 over 3 x to the power 3 over 2. Now basically here a half plus 1 is 3 over 2. 1 divided by 3 over 2 is basically the inverse of that, so it will be 2 over 3. So minus, so here negative a half plus 1 is going to be a half. So 1 divided by a half is a half. So that's what 1 divided by a half is 2. So that's why we have a 2 right there. And this is a positive, so this gives you a positive 2. So that means this sign is not affected, so it stays as it is. So now next we're going to just plug in the different limits. So we plug in the upper limit minus the values that actually have the lower limit. So now basically we're left with 12. So this gives you 12 minus this gives you 4 over 3. So when we subtract those, we're left with 32 over 3, and that is our answer. So now I have an exercise for you. These are numbers that I encourage you to try out to actually see how good you are with this basic introduction to integration. So just try this out and solve them, and then compare your answers to the answers that I actually give you on the right hand side of each one. So these are basically going to be 10 different questions that I encourage you to try out and get better at integration. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.